In today's lesson, we're going to be taking a look at basic logarithmic equations. I'm going to try to cover all the situations that will arise when you're working with these logarithmic equations. If you missed a lesson on the properties of logarithms, you're going to need that, so I linked that in the top right-hand corner. But the goal of today's lesson is to work through basic logarithmic equations solving for x. Afterwards, look at my next lesson on solving for more advanced logarithmic equations. All right, so looking at this first example here, we want to solve this logarithmic equation. The general strategy when you have a logarithmic equation to solve is you want to go to exponential form. So to go to exponential form, we want to take our base, which in this case is 3. We're going to raise that to 4, and that's going to equal x. The reason why this is true is what your logarithm returns is the exponent you raise your base to get the input. My input value is x. And if log base 3 of x is equal to 4, that must mean that 3 to the power of 4 is x. In which case here, we would have x is going to be 3 to the power of 4, which is 81. In general, it is good practice to ensure that the value we get for our logarithmic equation is actually inside the domain of my logarithm. You'll notice here that your log base 3 of x, has a domain such that x is greater than 0. Since 81 is greater than 0, this is in the domain, this is good, and we keep it. Let's take a look at the next logarithmic equation. So same idea here, I'm given a logarithmic equation, I want to go to exponential. This time my exponential will be x squared equals 25. And again, by getting that, you take your base raised to the 2 will equal 25. So now I can go ahead and solve this equation. Solving, we get x equals plus or minus 5. Obviously taking the square root here. And you'll notice here once again, your base of your logarithmic function must be greater than 0. So we cannot have a negative base. So the only possible answer for this is positive 5. Let's take a look at some more examples. So in the next example here, we're adding two logarithms. It's very important to notice that these two logarithms have the same base. Whenever you add two logarithms with the same base, you can change that operation to multiplication and put these together. Again, that's one of our logarithmic properties that is available in another lesson. So applying our logarithmic property we have. Now that I've applied my logarithmic property, you can see we have this down to a single logarithm is equal to a number here, in this case on the right-hand side. So once again, just like the previous two questions, we're going to go right to exponential form. Going to exponential form, I will have 2 cubed is going to equal the product of these. Well, we know 2 cubed is 8. I can go ahead and expand out the right-hand side, giving me x squared plus 8x plus 7. Bringing everything to one side and factoring, we get. And you'll see here, I bring everything to one side, I have my quadratic. A quick discriminant check tells me the discriminant here is 68, so I have two irrational roots. And then I had to go to my quadratic equation, and I'm getting negative 4 plus or minus the root of 17. Now you have to make sure that your logarithm itself is defined. These values are defined. You have to go to your original logarithmic equation here to make sure that each of these points is within. So when my logarithm here acts on x plus 1, x has to be greater than negative 1. And when my logarithm acts on x plus 7, x has to be greater than negative 7. So both of these together have to be satisfied for the equation as a whole to be true. So it must be the case that x must be greater than negative 1. So let's take a look at these two values as a decimal place. We can see where they lie on the number line. Taking a quicker look here we get. So again here, taking a look here, I get the two values here, negative 8.12 and 0.12. This is outside of my domain here, so the only admissible answer is approximately 0.1, which if you want to express this exactly, we would have our x value equaling. This is going to represent negative 4 plus the root of 17. And that would be our exact value for this logarithmic equation. All right, let's take a look at the next example here. So now we are subtracting two logarithms. Again, these have the same base. Both of these have a base of 4. So using our logarithmic properties, I can now change this operation to division, giving us. Now I went ahead and expressed this as a single logarithm. I can now go to exponential form, giving us 4 to the power of 3 is going to equal x squared minus 9 over x plus 3. So now we're going to go ahead and simplify this and try to bring everything to one side, giving us the following. And again here, if you take a look, I went ahead and evaluated that 4 cubed, multiplied across by x plus 3, expanded, brought everything to one side, and this factored quite nicely as a simple trinomial. And the values of x are 67 and minus 3. And notice right away here that you have to make sure that your values are within the domain. In this situation here, we have to ensure that both of these logarithms, our original equation, are defined. So the domain of this here is going to require x to be greater than negative 3. And for this situation here, we're going to need x squared minus 9 to be greater than 0. So let's look a little closer at what that implies for the domain. And you'll see here we need x squared minus 9 to be greater than 0. I went ahead and graphed x squared minus 9, just a quick graph of it. This is greater than 0 in two locations when x is greater than 3 and less than negative 3. So the domain here would be x is less than minus 3 or x is greater than 3. This is the domain required for this logarithm to be defined. And the domain here, like we had just talked about, is x must be greater than minus 3. So combining these two together, we would have x is greater than minus 3 intersecting with x is greater than 3. So the domain required for this equation to be true must be x is greater than 3. Therefore, right away, we kick out the minus 3, and the only answer for this is 67. Let's take a look at another example. So in the next example here, we're adding two logarithms. Again, same base of 2. We want to go ahead and put this together, change this to multiplication. This becomes log base 2 of x minus 4 times x plus 4 equals 3. Going to exponential, we get the following. All right, let's evaluate this and solve for x, giving us. And again, we have to check our domain here. I end up getting x is plus or minus the root of 24. when I solve for x here, but again, we have to go to our domain and see. So going to our domain here, we have two requirements. We have the situation that x minus 4 must be greater than 0, which is going to imply that x is greater than 4. And we also have the situation that x plus 4 must be greater than 0, which implies that x is greater than negative 4. So both of these situations here, if we kind of intersect both of those ideas, x is greater than 4 and x is greater than negative 4, will imply that this equation will be defined as long as x is greater than 4. So therefore, anything that is outside of that domain we have to kick out. If you take a look here, the x equaling negative the root of 24, we will have to omit that value. And the root of 24 is approximately equal to 4.89, which is just greater than 4 and therefore in the domain and in our answer. So again, the answer to this question is the root of 24. Also note you can express the square root of 24 as 2 to the root of 6. All right, that concludes our lesson on solving basic logarithmic equations. Take a look at my lesson on solving advanced logarithmic equations under my playlist. Thank you.